Hi, welcome. This is Professor Ridge, and today's lesson's 1.2, Exponents and Scientific Notation. Alright, so let's look at the first learning objective. Use the product rule of exponents. Okay, so the product rule of exponents listed here in the textbook, for any real number a, the natural numbers m and n, the product rule of exponents states that a to the m times a to the n equals a to the m plus n. Okay, so let's analyze this first before we actually do any problems. So if you recall that if I had like any number, say a to the third power, the definition for the exponent, the base is a, so we call this the base, and this is your exponent. That means a times a times a. And so if I had a to the fifth, that's the same thing as a times a times a times a. You're going to have 5 factors of a. 5 factors of a. A to the third, you're going to have 3 factors of a. So if I wanted to do a to the third times a to the fifth, because multiplication is associative and commutative, you can think of this a to the third as this first one, a times a times a, right? There's your 3 of them. And a to the fifth is, there's 5 of them. And then total, so back to our definition of what exponent is, we have the base a multiplied a total of 3 plus 5, which is 8 times. So you don't multiply 3 times 5, you add it. So that will be 8. Let's look at example 1 using the product rule. Write each of the following products with a single base. Do not simplify further. Alright, so the first one, t to the fifth, that's basically like the example I just showed you, but instead of a, it's t, right? And you don't have to show all that extra work that I did. You're just going to use the product rule, where if we're multiplying with the same base, you add the exponents. And of course, once you get practice of this, you don't have to show that step. You just in your head, 5 plus 3 is 8. And then that's our final answer. All right, moving on to B. So we got negative 3 to the fifth times negative 3. Now if there's no exponent here, it's actually a 1. That's one of our properties of exponents. We'll probably talk about that. Well, we can talk about it now. Anything to the first power is itself. So that's the exponent rule of an exponent of 1, right? So anything to the first power, it's itself. And you can go, it works both sides. So anything, any number is the same thing as that number to the first power. Alright, so now using the product rule, they both have the base of negative 3. And you want to put the parentheses in it because the way that our notation works is, 5 plus 1, I'll get back to that, 5 plus 1, so that equals negative 3 to the 6th. Okay, so just a real quick note here. Just the way notation works for math is if we had like negative, let me do a different number. So let's say negative 2 to the third power. This is to be interpreted as negative 1 times 2 times 2 times 2, which is negative 8. Now if I had negative 2 to the third power with parentheses around the negative 2, I interpret this as the base is negative 2 and we're multiplying negative 2 3 times. Okay, so it's really important to understand that notation, because now you can see on this one it doesn't matter because you get the same answer. But if that was to the fourth power, negative fourth, this is interpreted as -1 times 2 times 2 times 2 times 2, which is -16. And if I had -2 to the 4th power, so technically you should read this one as the opposite of 2 to the 4th power. So you do 2 to the 4th first, which is 16, and then you times it by the -1. Whereas this problem, this is actually the -2 4 times to the 4th power. So hopefully that makes sense. And that's going to be positive 16. Okay, so you get different answers. So it's really important to understand that notation. All right, moving on to example C here. So for C, we can extend this again because multiplication is associative and commutative. I can extend this rule to as many as I want, as long as they all have the same base, right? So if we didn't have associative and commutative, you'd have to do this first, and you get x to the 7th, and then you have x to the 7th times x to the 3rd, and then these you'll get x to the 10th. Okay, but we're not going to do it that way. We're going to extend the product rule, and as long as you're multiplying and they all have the same base, you just add the exponents. So 2 plus 5 plus 3 will get us 10. Okay, and then that'll be our final answer for that. All right, on to the next learning objective. Use the quotient rule of exponents. The quotient rule of exponents: for any real number a, the natural numbers m and n, and remember, natural numbers are your counting numbers, 1, 2, 3, 4, so on. So if we're defining it this way, we want m to be greater than m. Now if we change this natural numbers to integers, then you don't need this statement here. And the rule works the same, but anyway, let's move on. We'll talk about that later. So a to the m divided by a to the n is equal to a to m minus n. So to me this one makes sense, because if we're multiplying with the same base, we add the exponents. But if we're dividing with the same base, we're going to subtract the exponents. So that's the quotient rule. And again, we can kind of look at an example. Let's just put some numbers there. So if I did like x, we'll do a to the 5th over a to the 3rd. So see, 5 is bigger than 3. And then we're going to have a to the 5th, as before, definition of exponents. A to the 5th means a times a times a times a, 5 factors of a. A to the 3rd is 3 factors of a. Okay, now we can use rules for fractions. We're canceling. So if I have a divided by a, that's going to just get you 1. So we can cancel 3 factors of a on top and 3 factors of a on the bottom, and we're left with just 2 factors of a on top over 1, which is the same thing as a squared. So if we had 5 factors on top and 3 on bottom, and we cancel 3 factors of a, 3 common factors, 5 minus 3, so that's the rule. We can do it this way. We can just say 5 minus 3, and that's 2. So that's the shortcut. So actually we wouldn't do this. We would just go from a, let's do a different example. A to the 7th divided by a to the 2nd. So we're dividing by the common base a, so they both have a. So 7 minus 2 would be 5, and you have 5 a to the 5th. Okay, let's look at example 2. Using the quotient rule, write each of the following products with a single base. Do not simplify further. Okay, a, we have -2. Basically, we just want to use the quotient rule, just that first step basically. If we were going to simplify, we just want to make sure we got it. So here we got negative 2 to the 14th divided by negative 2 to the 9th. Since the bases are same and we're dividing, we can use the quotient rule for exponents. And we're going to leave the base alone, so that's negative 2. And then we're going to subtract the exponents. So we get negative 2 to the 5th. And then normally, right, if it didn't say do not simplify further, then we get out our calculator. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 would be negative 32. Or, use the exponent button on your calculator. Would be even better. All right, so B. So t to the 23 over t to the 15th. And then we're going to subtract. So if the bases are the same and you're dividing, you subtract the exponents. So 23 minus 15, I almost said divide. So 23 minus 15, I believe that's 8. And then that will be your answer. All right, and then C, we got z square root of 2 in parentheses to the 5th divided by z square root of 2, and then that's it. So remember what I was saying before. So our base on the top is z square root of 2, this whole thing. And then on the bottom, I can rewrite it as z square root of 2 to the 1st. And then 5 minus 1 would be z square root of 2 to the 4th. So 5 minus 1. Oh, I didn't show that step. But again, once you get comfortable, you don't have to show that step. On to the next learning objective. Use the power rule of exponents. The power rule of exponents for any real number a and positive integers m and n. The power rule of exponents state that a to the m raised to the power n is equal to a to the power m times n. All right, let's look at why this works. So let's change the variable to x this time. X to the 3rd, and then I'm going to raise that to the power, we'll just keep it simple, square, right? X to the 3rd squared, if I think of this as the base, 3, and then I have the square, that means x cubed times x cubed. Well, now I can use the power rule. If I'm multiplying with the same base, okay, it's again, multiplication's commutative and associative. So if I'm multiplying with the same base, I can just add these exponents, 3 plus 3. But isn't that the same thing as saying 3 times 2? Right? So the shortcut then is going to be 3 times 2, and we don't have to show this work here, and then we get x to the 6th. Okay, let's look at example 3. Using the power rule, write each of the following products with a single base. Do not simplify further. Okay, so a is x squared raised to the 7th power. And again, if we have a power to a power, we're going to just multiply the powers. So 2 times 7 is 14. So this will be x to the 14. B, 2t to the 5th raised to the 3rd power. And again, we're just practicing this one rule right now, so we're not simplifying further. So on this one, we're just thinking 2t is the base. We're raising it to the 5th power, and then we're taking that and raising it to the 3rd power. So power to the power we're going to use the power rule. So 2t, and you have to put parentheses here, and then 5 times 3, and then we get 2t to the 15th power. All right, moving on to the C. Same thing here. We got negative 3 to the 5th to the 11th. So if this didn't tell us to do not simplify further, right, we would have to do more here, but we'll get to that, I'm sure, in later examples. Now on this one, we got negative 3 power to the power, so 5 times 11, which is 55. And again, from that discussion we had earlier, you need the parentheses around the negative 3. Even though this is to an odd power, you can actually drop those parentheses because it'll give you the same result. But for right now, we're going to need it. Okay, moving on to the next learning objective, use the zero exponent rule of exponents. The zero exponent rule of exponents, for any non-zero real number a, the zero exponent rule of exponents states that a to the 0 is equal to 1. So any number to the 0 power equals 1. Now at first that may seem a little odd, but if you think about it this way, let's go back to the rule we just talked about. So we know that if we're dividing any number, let's use different letters. Let's say we had 5 divided by 5. Well, we know that's 1, right? So anything divided by itself is 1. So if I had, let's say, x to the third divided by x to the third, hopefully you would agree these are the same number. X third divided by x third is 1 using that rule. Anything divided by itself is 1. But also, from the exponent rules we just developed, if you're dividing with the same base, we're going to subtract the exponents. So 3 minus 3 is 0, and since x to the third divided by x third, we know that's 1, x to the 0 has to be 1. So you have to define 0 exponent to be equal to 1. Okay, so that's where the rule comes from. Example 4, using the zero exponent rule, simplify each expression using the zero exponent rule of exponents. Alright, so basically what we just, like the example I just gave you, we're going to use the exponent rule 3 minus 3, which is 0. Anything to the 0 power using the zero exponent rule is 1. Alright, moving to B. Now on this one, remember, negative 3, even if you have a number next to the letter, there's a times right there. We just don't write that dot. Okay. So this part, we're going to look at this part here. So that will get us negative 3, x, 5 minus 5 is 0. And x to the 0 is the same thing as 1. And then anything times 1 is itself, so we get negative 3. So that's our final answer there. All right, moving on to C. J squared k in parentheses over j squared k times j squared k cubed. All right, on the bottom, right, so if we think of j squared k as the base, you can see on the bottom, again, we can put a 1 there. 1 plus 3 would be 4. So j squared k to the 4th. And then 4 minus 4, j squared k to the 4 minus 4 would be j squared k to the 0. And once you get the hang of this, you don't have to show all these steps, right? You can pretty much in your head think about it. Oh yeah, that's going to be 4 over 4, and then 4 minus 4 is 0. So pretty much once you get the hang of this, you can probably not even show any work on that problem. But I like to show all the detail in the beginning, just to make sure we're on the same page. And then D, same thing here, right? You're going to go 2 minus 2 is 0, and then 5 times 1 will be 5. So I'm not going to do that one. All right, moving to the next learning objective. Use the negative rule of exponents. The negative rule of exponents for any non-zero real number a and natural number n. The negative rule of exponents states that a to the negative n equals 1 over a to the n. So at first, for a lot of people, this one's not very intuitive either. It doesn't really make sense the first time you see it. But we can do the similar argument we did with the zero exponent rule. So if I did something like x to the 3rd over x to the 5th, and I do now if I ignore remember in the rule that this number on top is supposed to be bigger than the number on the bottom, you can actually rewrite the rules and just call them integers, and this is going to be valid. 3 minus 5 is negative 2. But if we go back to the definition of x cubed over x to the 5th, x cubed is x times x, so 3 of them. X to the 5th is 5 of them. 5 factors of x, and then we cancel, and you can see that we're canceling 3. We have 1 on top, or 0 on top, so that's 1. There's always a factor of 1 left over. And then on the bottom, we got x squared. Okay, so then we started with the same number, so these two results have to be equal to each other. So you can see x to the negative 2 is the same thing as 1 over x squared. So negative exponent, you can think of it this way. If something has a negative exponent, that's going to take that and push it to the other side of the fraction bar. It's going to go to the bottom. And actually, I tell my students all the time that if we had a fraction like this, so these have different bases, but this negative exponent is actually going to push that one to the bottom, and this negative exponent is going to push that one to the top. So we're going to get b to the 5th over a to the 3rd. So the kind of the rule I create in my mind is I think, okay, if I take a base with its exponent and I move it across the fraction bar, doesn't matter if it's from top to bottom or bottom to top, it changes the sign of the exponent. So if it's negative 3 on top, it's positive 3 on bottom. And then this one's negative 5 on bottom, it'll be positive 5 on top. Okay, so if you move across the fraction bar, it changes the sign of the exponent. So just kind of keep that as a little side rule. Example 5, using the negative exponent rule, write each of the following quotients with a single base. Do not simplify further. Write answers with positive exponents. Alright, so starting with A, we have theta to the 3rd over theta to the 10th. And we want to write each of the following quotients single base. We want positive exponents. So here's the way I do it. So I'm going to modify my quotient rule, and if I want positive exponents, we're going to, if we're dividing, we subtract the exponents. But you're going to take the bigger number minus the smaller number to get positive exponents, and the one that has the larger exponent, that's where the factors remain. So what I'm going to do is, basically this is the smaller one. I'm going to think of that going down there to be the minus 3. So theta of 10 minus 3. So that's the way I do it. I don't know if this book shows it that way or not. No, they went to do, let's see how they do it. They did 3 minus 10 and gets negative 7, theta to negative 7, and then they did use the negative exponent rule. So the way the book presents it is, which actually is a little bit of a contradiction, right? Because it doesn't matter. So they go like this, 3 minus 10, which is fine. Sometimes I do it this way. And then this is a negative exponent. We want positive exponents. So using the negative exponent rule, that gets pushed to the bottom and you get the same answer. So either way is fine. Either method works. All right, moving on to B. Z squared times z over z to the 4th. So again, we can simplify the numerator. You can put a 1 there. So that's z. The 2 plus 1 is 3. And then we're going to subtract. Again, you could do it either of these methods. Me personally, I would go 4 minus 3. The bigger ones are on the bottom. So if you think about, they're canceling, they're going to be left on the bottom. So that's the other way to kind of think about it. So if I cancel 3 of them, I'm going to do the 4 minus 3 on the bottom. And I'm left with just the 1 on the bottom. Z to the 1st, which is just z. All right, and then the last one, C there. Let's see, negative 5t cubed in parentheses to the 4th power. So again, the base is everything inside the parentheses, and you can see they're the same. So I'm going to go 4 minus 8, which is negative 4, and then push it to the bottom, or I'm going to do my shortcut. There's more on the bottom, so I'm going to go 8 minus 4, and they're going to be left on the bottom. So negative 5t cubed, and I'm going to go 8 minus 4 on the bottom. Again, you don't have to show that step. Just 8 minus 4 is 4. Okay. And again, I don't care which method you use personally. They're both good methods. Moving on, the next learning objective, find the power of a product and a quotient. The power of a product rule of exponents for any real number a and b, and integer n. The power of a product rule of exponents states that a times b, so that's the product of ab raised to the power n equals a to the n, b to the n. Some teachers, would say, you can think of this as like a distributive property. So if we have, let me backtrack on that for a second. Let's just do 3 times x to the 4th power. So from x, just the basic meaning of powers, a base to an exponent, we're going to take the base, we're going to have 4 factors of whatever the base is. So the base is 3x, so we want 4 factors of 3x. And whether I write the dot in between or not doesn't matter. Again, multiplication is commutative, associative, so I can basically remove the groups since it's all multiply, and then rearrange the order. Put all the 3's together, put all the x's together, and then group it that way. So that's using the commutative and associative properties of multiplication. And then 3 with 4 factors of 3, that's 3 to the 4th. And 4 factors of x, that's x to the 4th. Okay, so the shortcut is you're just going to raise each factor in the product to the power, whatever the power is. So if I have x times y to the 6th power, the shortcut is you're just going to take x to the 6 and then y to the 6. So it kind of has that distributing feel, right? So x to the 6, y to the 6. All right, looking at example 7, using the power of a product rule. So for a, we have ab squared raised to the 3rd power. So again, you're going to raise each of the factors in the product to the 3rd power. Right, so a to the 3rd, well, that's just a to the 3rd. And then here we got to use power to the power, right? Power of a power. So 2 times 3 is 6. And of course, once you get practice at this, you can skip that step and just go straight to the answer. B, write the answers with positive exponents. Simplify the products as much as possible. Okay, I was just checking that. 2t to the 15th. Oh, there's parentheses. So again, that's going to be 2 to the 15, t to the 15. So let's see, that's 1,000. All right, get out my calculator on that one. Okay, so punch it in my calculator, 2 to the 15th. Again, if you don't have a calculator, remember I told you about the Desmos one online. You can use that one. Here, let me show it to you again. Let me pause. Okay, so Desmos, just desmos.com, 2 to the 15th. It's 32,768. Okay, so that's a nice free calculator. Plus it has graphing. And again, remember, when it comes to the midterm and the final, you're not allowed to use a graphing calculator. So you'll have to make sure you have a regular scientific calculator for the midterm and the final. All right, C. So we got negative 2w to the 3rd. That product raised to the power 3. So it's the product of negative 2 times w to the 3rd. That product raised to the power 3. Okay, so we're going to use the product rule. So negative 2 to the 3rd, w3 to the 3rd, and then we get negative 8, negative 2 times negative 2 times negative 2, and then power of a power, that'd be w to the 9th. Okay, and then that's our final answer there. D, let's see here, negative 7z to the 4th. So basically the same thing, just on the bottom of the fraction. So it's negative 7 to the 4th, z to the 4th. So that's going to be 1 over 7 to the 4th is, and get Desmos. Oh, this is, again, remember what I said about the parentheses. Look, if I put in negative 7 to the 4th, see, it's negative 2,401. But if I put parentheses around it, so the way that this is interpreted is this is the opposite of 7 to the 4th. So you're doing 7 to the 4th first, and then taking the opposite of that. This is interpreted as negative 7 to the 4th. So if you have the parentheses. Okay, so it's, one answer you'll get positive, the other one you'll get negative. So it's important to know which one it is. So what did we say the answer was? 2,401, and then z to the 4th. Okay. And then E, so will be negative. I'm just going to go ahead and do it here. So we're going to multiply. negative 2 times 7 is negative 14. 2 times 7 is 14. And then this is the negative one, so it's going to get pushed to the bottom of the fraction bar. And that will be my final answer, f to the 14 over e to the 14. The power of a quotient rule of exponents for any real number a and b and in any integer n. The power of a quotient rule states that a divided by b, so that's your quotient, a divided by b raised to the power n is a to the n over b to the n. So it kind of has that similar feel like the product one, where you're going to do that distributive, so x over y, so if I had xy to the third, well, that means x over y times x over y times x over y. Okay, and again, we can drop the parentheses, but you can leave it, doesn't matter. So let's see, we got, if we want to multiply, now think about multiplying fractions. The way you multiply fractions is you just multiply straight across, right? So the numerators and the denominators. So we have x times x times x, y times y times y. And then on the numerator, on the top, we got x to the third, denominator, y to the third. Okay, so basically we're just going to raise the numerator to the n power and the denominator to the n power. So again, it kind of has that distributive feel, even though it's not the distributive property. Example 8, using the power of a quotient rule, simplify each of the following quotients as much as possible using the power of quotient rule. Write answers with positive exponents. Alright, so A, let's see, we're going to do 4z to the 11, so 4 over z to the 11, so that's our quotient to the third power. We're going to raise the numerator to the third power, the denominator to the third power. So 4 times 4 times 4 is 64, and then power to power rule, we're going to multiply 11 times 3 is 33, and that's your final answer there. Okay, moving on to B, P over Q to the third raised to the sixth power. So again, we're going to raise the numerator to the sixth power, the denominator to the sixth power. So the top, P to the sixth, there's nothing to do there. Bottom, we got a power to a power, so we multiply Q to the 18. And then that's your answer. Now, don't try to do anything right with the 6 and the 18. Those are exponents, and these have to be the same base to be able to do something to simplify it. Okay, so that's your answer. P to the 6 over Q to the 18. Let's see if any other ones. Let's do D. So we got J to the third, K to the negative 2, raised to the fourth power. So again, we're going to do, now there's two ways you can do this. You can simplify using the negative exponent rule and move this to the bottom. So I can do this. And then you can use the quotient rule. So power to a power, power to a power. So quotient rule, we're going to, again, has that distributed feel. So it would be the numerator to the fourth power, denominator to the fourth power. And here, I was saying power to power because I was thinking this next step. Power to power, you're going to multiply. So that would be 3 times 4 is 12. And then 2 times 4 would be 8. Okay? And then again, these are different bases, so you can't do anything else. That's your answer. What I was saying before, the other way you could have done this is instead of converting it that way, we can do the product raised to a power. So we can do J to the third to the 4th power times k to the negative 2 to the 4th power, which is j to the 12th, k to the negative 8, because negative 2 times 4 is negative 8, and then use the negative exponent rule, which will get you that answer. Okay, so either way is fine. All right, moving on to the next learning objective, simplify exponential expressions. Simplifying exponential expressions. I wanted to really highlight this in the book. Recall that to simplify an expression means to rewrite it by combining terms or exponents. In other words, write the expression more simply with fewer terms, right? That's what simplify means. The rules for exponents may be combined to simplify expressions. All right, let's look at A here. So let's see, we have 6 times m squared times n to the negative 1, that whole quantity raised to the 3rd power. So again, there's a couple ways that you can work this. Like the previous example, I can take care of this negative first, or I can take care of it later. It doesn't matter. So I can do a product. Think of this as a product raised to a power. So I'm going to raise each factor to that power. So 6 to the 3rd is 216. 6 times 6, 36 times 6, 216. M squared to the 3rd, so that's power to the power. So 2 times 3 is 6. And then negative 1 times 3, this power to power again. Negative 1 to 3, negative 1 times 3 is negative 3. And then we're going to move this negative exponent down to the bottom of the fraction. So we're going to you can take any whole number and write it over 1, right? So anytime you don't have a fraction, you can think of it as a fraction. So I can take this expression, put a 1 on the bottom. The n to the negative 3 gets moved to the bottom and becomes positive 3 on the bottom. Right? So that's the way I kind of do it. Hopefully that makes sense. All right, let's look at B here. So we got 17. Now they're all multiplying, so you can just what I would do is just straight add. So it would be 17. Okay, I'm going to skip rewriting it down for space here. So it'll be 17 to the 5 plus negative 4 plus negative 3, which is 1 minus 3 would be what? Negative 2. And then now, again, put this over 1, and then this is going to get moved to the bottom. So another way to think, there's a couple different ways you can think of negative exponents. One way is it's a reciprocal. So it's 1 over 17 squared. And then 17 squared is, I believe it's 289. Better check that. Yeah, that's 289. Okay, so there you go. Let me do a new page. All right, let's try C. So let's see. U to the negative 1, V to the negative 1, and then squared. So I'm going to simplify in here first. And remember what I said about an alternate way to think of the exponent rule. If you have a negative exponent and you want to make it positive, you just move it to the other side of the fraction bar. So this one's going to go up. So if I think of it that way, I'm going to have this as, so this V to the first comes up. So I have the V that's there, the V that's coming up, and I'm going to go ahead and put a 1 on this one. So V1. And then this one's going to the bottom. And then I have the square. 1 plus 1, since those are the same base, is 2. Then U the first. And now I'm going to do the quotient to a power of a quotient. So I'm going to raise each of these to the second power. So power, so I get b to the fourth on top and u squared on bottom. And that's my final answer there. Again, that's not the only way to do it. That's just the way that I chose to do it this time. Another time, maybe I do that rule first and kind of distribute it, and then I take care of the negatives. So I would end up at the same answer no matter which way I did it. All right, D. So same thing here. Let's see, negative 2, a to the third. I'm going to go ahead and move this to the bottom, b to the 1. 5. I'm going to move the a squared to the bottom, and then b squared. Okay, so remember, negative exponent, you can move it to the, so this is a negative number. This is a negative exponent. Negative exponent, you move it across the fraction bar and it changes the sign. Okay, this one, I can move that one across the fraction bar. Okay, so now, let's see here, it's multiplying, so I'm going to multiply the numerators. Negative 2 times 5 times a cubed b squared. Multiplication is associative and commutative, so I can switch the order like that. And then we like to write things alphabetical order, so a squared times b. So we get negative 10 on top. A cubed divided by a squared, I'm going to do the 3 minus 2, that's a to the first on top. I'm not going to write the 1. And b squared divided by b to the 1, 2 minus 1 is 1. And I'm not going to write the 1 over 1, right? Since I subtracted. So that's going to be my final answer right there. I don't like that. So let's see here. Okay. E. Let's see if I can squeeze E on here. X squared square root of 2 to the fourth. X squared square root of 2 to the negative 4. So I'm going to do x squared, so power, so 2, 4, and the square root of 2 to the fourth. The same thing here. Oh, you know what? Actually, I'm working too hard on this one. Let me go again at that one. All right, so that was E. So E, I just noticed something. Those are exactly the same base. So there's two ways we can approach this. We can bring this to the bottom, or since these are the same base, just think of it as a to the fourth times a to the negative 4. Well, that's the same thing as you're going to add the exponents, so 4 plus negative 4 is 0. Okay? So I have x squared square root of 2 to the 4 minus 4, which is x squared square root of 2 to the 0, and we know that anything to the 0 is 1. So the answer is just 1. A little tricky on that one. I was going to go all at it, work all that stuff out. I would have got to 1, but with a lot more work. All right, on this one, let's see, we got 3w squared to the 5th over 6w to the negative 2 squared. So I would do 3 to the 5th, w, 2 to the 5th, which is 10, and then 6 squared, which is 36. You know what? I'll go ahead and write 6 squared. 6 squared, And then negative 2 times 2 is negative 4. And do you remember what I said about my shortcut, negative exponent? I'm going to move this to the top and be positive 4 on top. So I have 3 to the 5th, W10, W4 on top, 6 squared on bottom. Now, do I want to simplify numbers here? So 3 to the 5th is 243. And then I'm going to add the exponents, same base, add the exponents. So 10 plus 4 is 14. And on bottom, that's 36. And I think this will reduce because 6 is 3 times 2, so I can divide 9 out of both of these. 243 divided by 9 is 27. And 36 divided by 9 is 4. And then I have the W14 that stays there. Okay. All right, that's the last one. Okay, moving on to the last learning objective, the scientific notation. Scientific notation. A number is written in scientific notation if it is written in the form of a times 10 to the n, where the absolute value of a is between 1 and 10. It can be equal to 1, but not 10, right? So it could be 9.9999. This could be just exactly 1. And n has to be an integer, okay? All right, so example 10, convert to standard notation. So the way that I do it is basically we should know that when you multiply by 10, so if I had like 5 times 10, that gets you 50, right? So if the decimal place was right here and we multiply by 10, it actually moved the decimal place 1 place. So the power, so 10 to the 3 is the same thing as 1,000. Right, the shortcut is you count the zeros, 1, 2, 3. 10 to the 4 is 10,000. Okay, 4, 1, 2, 3, 4. And then if you're going in the negatives, so 10 to the 0 is just 1. 10 to the negative 1 is 0.1. 10 to the negative 2 is 0.01. Okay? All right, so the way you do it is I typically look for I start on the left, the first non-zero number, 2, and to the right of it, you're going to put a dot. And then you're going to count how many places you're moving the decimal place, and that's 3, 6, 9, 12, 15, 18, 21, 22. So this will be equal to 2.4, and then all these zeros can be dropped off, times 10 to the, I forgot what I said. Let's see, 3, 6, 9, 12, 15, 18, 21, 22. 22. All right, so same thing here. We're going to put the decimal place right there. First non-zero number, 1. To the right of it, and then we're moving 1, 3, 6, 9, 12, 15, 18, 21. So that one's going to be 1.3 times 10 to the 21. Okay, and then this is, we're going to put the decimal point there. So 1 point, you probably don't need that 0. I'm just going to write it. It's just 1 times 10 to the 3, 6, 9, 12. Now this one, look at, so you start at the right, first non-zero number is 9, and you put the decimal place first dot, the first to the right of the first non-zero digit. So 9.4. Now you got to count How many places did we move it? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's getting, we want this number to get smaller, so that would be negative 13. All right, so 9.4, so negative 13 is gets you in the decimal places. Probability of being struck by lightning in a single year is this number. So we're going to put the decimal point to the right of the first non-zero number. So 1.43. And then we have to move it 1, 2, 3, 4, 5, 6 places. And then we want this number to get smaller. That's kind of the way I think of it. I want this number to get smaller, so that will move the decimal place to the left for negative. Okay, so I'm looking at this one. Okay, so example 11, now we're going the other way. Convert scientific notation to standard. So the way you do that one is basically multiplying by powers of 10 is moving the decimal place. If it's positive, right, it's getting bigger. If it's negative, it's getting smaller. I'm talking about this number is getting bigger or smaller. So if for instance, if I took 3.5 times 10, right, obviously that's going to be a bigger number. So that would be that would move the decimal place one place to the right, so that would be 35. Okay, so if I do it 2 squared, well, that's the same thing as times, you're multiplying by 100, and you'll see that's 350. Okay, so if it's moving to the right, it's getting bigger. This will be positive. It's moving to the left. It's getting smaller. It would be negative. So I'm going to move the decimal place 14 places to the right. So this would be, it's here. So I'm going to move it 3 places to get it to the end. 5, 4, 7. So 3, and I need 14. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 3, 3, 3, 3. So we can count. There's 3, 6, 9, 12, 13, 14. That's what we wanted. Okay, so that's A. You can do B on your own. C, this one's getting smaller, so we're going to go this way. So that's 1, and then we need 6 more places. So 1, 2, 3, 4, 5, 6, 7, 9, 1. Right? So the place it was originally there, 1, 2, 3, 4, 5, 6, 7. So you're going to have 6 zeros, 7, 9, 1. So the decimal point, you don't need to write this first 0. A lot of people do. Sometimes I do, sometimes I don't. Okay, so that'll be in standard notation. Okay, so for using scientific notation, when we do this one here, we're going to, because multiplication is commutative and associative, I can rewrite this, drop the parentheses, and I'm going to switch these two numbers. So it'll be 8.14 times 6.5, I'm going to figure that out, times, and then I'm going to put the 10 to the powers together. And on this one, I'm going to use exponent rules. Negative 7 plus 10 is 3. And then with the calculator, I'm going to do that part, or by hand, depending on what it is. So that is, what, 52.91. And then do we want it in scientific notation? Now here's the problem when you do this. This is not scientific notation because this has to be between 1 and 10. So we need to move the decimal point to become right there. So this portion, I'm going to move the decimal place to first place after the first non-zero number. And remember, for this number to become that number, it has to get bigger. So I'm timesing that by 10 to the 1 power. And then I have the 10 to the 3, and then 1. Now I'm going to use exponent rules here. It's 5.291 times 10 to the 4. All right, let's do one more. We'll do the divide one, D. So if I have 1.2 times 10 to the 8 divided by, I'm going to use the fraction bar, 9.6 times 10 to the 5th. I can split this up into two fractions. And I'm going to, with the calculator, do that portion, which is 0.125. And then exponent rules here. So 8 minus 5 is 3. And then we want it in scientific notation, so the decimal place has to go there. So that's going to be 1.25. I'm ignoring the 10.3. Just looking at this number. I want this number to get smaller, so I got to move this to the left one place. So if I go left one place, that's a -1. And then I have the times 10 to the 3. Now use exponent rules on this portion. So it's 1.25 times 10 to the -1 plus 3. It's 2. And this is my final answer here. This is my final answer on that one. All right, and I'll leave the rest for you. Okay, so that brings us to the end of that lesson. And then just do the exercise set for homework on that one. And remember, on the book, I had a couple questions about it. So let me show you in the book. Just on the website, you just keep scrolling down until it says 1.2 section exercises. And then you do all the exercises, all the odds, 1, 3, 5, so on. Okay? Unless I told you differently. All right, have a good day, and I will see you soon.